All right. So, is everyone able to see my screen? Okay, great. Thank you. So, first of all, let me introduce myself. My name is Jaimin Patel, right? And I have over 12 plus years of experience in software industries. I have worked with a couple of product development companies, and last 4 years I'm associated with big data and Hadoop. So I got an opportunity to work on this technology in one of the project, and I have basically implemented it from the scratch, the one of the platform using this technology, and that's where I started my career with big data and Hadoop 4 years back. And since then, I have done a lot of work on these technologies day in day out. I'm also using a lot of machine learning algorithms and Spark and related technologies basically, which helps you to play with big data. Apart from that, I also do a lot of consulting work on these technologies. So I do consulting to some companies, some corporates who basically have who needs to solutionize their products in this space in using these technologies. So I do that. And I also get associated with a lot of corporates to do corporate trainings where I can share the knowledge with like-minded people like you. And that is one of the reason why we are meeting here. So I do a lot of corporate trainings and I have trained over 1,500 plus people across the globe. So this is a slide that we have prepared just for my introductions. Nothing great. Just a few brief points that we have mentioned about my career, what I have done so far. So that's pretty much about myself. And apart from that, I also want to introduce a little bit on the Simply Learn first before we get to the actual training topics. So this is about Simply Learn. I'm sure all of you have done a lot of research to join this training. It's world's largest certification training destination. They provide training on various areas. They cover a lot of geographical locations, and that these are the corporates whom they have given delivered trainings in this space, like right from the project management to the IT security to the big data analytics, virtualization, cloud computing, finance management, everything. So all these topics that you can see, they have experts who deliver training on these areas and they train professionals like you. Okay. So that's about that. And of course, there is all the trainings, in fact, have an online classroom phase where most of the training now they are going by online, where people from different geographical locations can get together and learn from each other. So in our class also, I'm sure some of the people are joining from US, some of the people are joining from India, and maybe from different locations. So that is what happens in most of the batches, so that when you learn together, you will also have a good learning experience. People from different backgrounds join this class, so they share their viewpoints, they share different questions that they have as per their experience, and that would really help others to learn and gain that information, right? So that is one of the important reason why Simply Learn provides this diversified, I mean, basically training which includes people from diversified backgrounds. Okay. So you can always read about the slides. You have LMS. So there is something called Learning Management Systems provided by Simply Learn, where you can log into the LMS with your username passwords. Once you log into this, you can click on the My Courses, where you have all the courses available which you have registered for, right? And then you can click on the the test. So basically all the course related details are available in the course section, and there are also tests which are available in this section, which will basically give you questions on the topics or the training that you have enrolled for. It is for your self practice purpose. Okay. And then you also get to see interesting so there are basically here, as you can see, when you click on the course view all the topics, you will get to see all the topics with, as you can see here, there is a lesson 1, lesson 2, like that different lessons will be available, and each lesson will have corresponding slides available here. You can view that, you can download it. So everything is possible here in the learning management system. So it's a one place where you can get all your materials related to your training, right? And all the slides that we'll be covering are available in this section. Okay. And of course, other stuff you can always browse it in your learning management system. There is also an active community which is available in the Simply Learn. So please join that. There is something called Simply Talk that they have introduced recently, which is an active community where they basically ask people to join that. It's called Simply Talk, where you can join it, and then experts on that subject would have also been logged into this. So whenever they see your questions, they would basically answer that, and even some other people can also answer your questions, right? So it will be a great learning together. It's a community which is definitely recommended to be joined, where you can share your knowledge as well as gain knowledge from the other experts. All right. So this is about introductions to the Simply Learn, and also I have briefed you about myself. So let us get started with our topics. What I would do is I will start with the agenda items for today, and then we'll get going from there. Okay. So let me just share the slides where we will go ahead with the topics of what we are going to discuss today. So this is the agenda for this training, all right, which basically covers about introduction topics to big data and Hadoop. So that is our first topic. We are going to start with that. Then we will definitely start with getting started with Hadoop. We'll understand core in detail architecture of Hadoop. That's third topic, which is Hadoop architecture. We'll also do Hadoop deployment. That when setting up the Hadoop cluster, I'll help you understand how to do that. Then we will basically start with the core components of Hadoop, which is HDFS and MapReduce. We will understand their architectures, how do we store data, how do we process data using HDFS and MapReduce. And then we will also cover advanced HDFS MapReduce topics. We will also do a lot of hands-on in these topics. Once we complete core Hadoop, then we'll move on to the ecosystem components of Hadoop, where we will start with Pig, Hive, HBase, right? And then we will also talk about Zookeeper, Scoop, and Flow. Apart from that, we are also having commercial distributions of Hadoop. Okay, and then we'll talk about the Hadoop administrations and troubleshooting. I'll just give you an overview on that. Sure, Uday, but I would expect you to do that by yourself. Can you just do that quickly? All right, cool. So let us get started, and let me just open the first slide, which we wanted to understand, which is Introduction to Big Data and Hadoop. That's our first topic. Okay. Here, one important thing which we want to understand is, whenever we want to learn a new technology, right? What are the first two questions that comes to our mind? We want to understand what is that technology and why it is important for me to learn that. Correct? And that is the reason why we are basically learning about these two questions with respect to big data and Hadoop. We want to understand what is big data and why big data is important by definitely going through different case studies. Apart from that, we are also going to learn about what is Hadoop and what kind of advantages Hadoop provides. Right. So we'll basically start with these two basic questions with respect to big data and Hadoop. Let us try to understand them. Once we understand these questions, then we will be able to appreciate the overall Hadoop framework in a better way. Okay. So let's get started. The first thing that I would like to talk about is with respect to big data. So let me ask you this question. What is big data to all of you? Right, before I give a definition, and I'm sure some of the people are actually joining from the previous batch as well. They would be aware of this question. But let's say people joining new, can you just tell me what is the big data for all of you? You can think of any definition. You can basically tell me any information that you think you have or you know about big data, which is absolutely fine, right? We just wanted to share the knowledge, so feel free to let me know whatever you think, and I'll tell you then what is the formal definition. So let me know what is big data to all of you. Okay, so I got a couple of responses. Yes, Vijay, you wanted to ask something? Vijay, you had any? Okay, no, I have muted you. Let me just unmute you.
Amen.
Yes, yeah, tell me.
Okay. Yes, now I can hear you. I also wanted to just say that I could not hear anybody else either. So.
Yes, that is because we purposely made everyone to be on a mute, right?
Okay.
That is how we follow that is like a policy that we follow for all the classes.
Okay.
Just to make sure that there is no disturbances, right?
Sure.
So what you do is like whenever you have any questions, you can raise your hand. There is an option called raising a hand, or you can type your questions in the chat window. Everything works fine.
Sounds good.
All right. Thank you. All right, cool. So There are a couple of information people have shared that's really good. So yeah, Uday says, as the word says, big, huge amount of data. Yes, absolutely right. Raj says huge amount of data in terms of volume. Correct, that's right. All right, so good. So these are the information shared by the people. So of course that is very valid, that as the name suggests, big data, that means huge amount of data, right? And of course we are talking about heavy volumes here. That's definitely a true definition. But then, can we say that if it's a huge volume of data, it's a big data? Well, the answer is no. We need to also look into some other parameters. So let us try to understand the formal definition of big data provided by IBM. Okay. So this is the definition of big data which is provided by IBM. Let me just open this. Right. So let us understand this. Basically, big data has been categorized into three different buckets. These are the three characteristics which IBM says any data, if it has, then it is considered as a big data. So what are these? They are also referred as three V's. The first is volume, then you have velocity, then you have variety. Now let's talk about volume. Volume stands for huge amount of data, okay, which means it's actually something like this. Basically, uh, whenever you store data in a, if you really want to understand like what do you mean by huge amount of data, normally it's a terabytes and petabytes in size. That is what we mean by huge amount of data. But there is a scenario where I mean, if you really want to understand, just not by going with the size, but then one will have a question which says, why 1 terabyte only? Can I have, let's say if I have, let's say 1 GB of data, can I say it's big data? So to answer that, we can understand it in a very simple manner, where if your data cannot be fit into a single machine, all right, whenever you are storing a data and if it cannot be fit in a single machine and it needs more machine to store the data, then yes, that means there is a huge amount of data. Yeah, yes, Arokia, I can see your chat. Okay, you have any questions? Okay, perfect. By the way, your name is Arokia, right? I mean, is it? Am I pronouncing it correctly? Oh, Mary. Okay, I'm sorry. So I'll I'll remember that. Thank you. So by the way, one thing I just wanted to make sure that here everybody is asking me the questions through chat window, and that's a normal mode. So we encourage people to type your questions in the chat window. What I'll be doing is I'll be whenever someone asks a questions, and if it is really I mean, what I will do is I will basically read out the questions and then I'll answer that, right? So that way people will get to know about others questions also, so that they'll also understand that what others are asking, and we will have a learning together, right? So don't worry if you are not getting what others are asking or what others are writing. It's absolutely fine. I'll be reading out the questions as and when required. All right. Great. So let's continue. So I was talking about volume. Volume means huge amount of data, about terabytes and petabytes in size. But as we discussed earlier, if I have huge amount of data, can I say it's a big data? Well, the answer is no. We need to also look into some other parameters. For example, velocity. Now, what do you mean by velocity? So let me give you two basic examples, two scenarios. First scenario is, let's say we have 1 terabyte of data which comes to our system every day. All right. And the second scenario is we have 1 terabyte of data which comes to our system after 1 year. So as you can see, the difference between these two scenarios is, in the first scenario, we are generating 1 terabyte of data almost every day. But in the second scenario, we are taking 1 year long time to generate this much data, right? So that is the difference of velocity that we need to understand. In the first scenario, almost every day, that means in a very short span, we are generating huge amount of data, which means the frequency of generating huge data is very high. That means our velocity is very high. But in the second scenario, we take 1 year time to accumulate 1 terabyte of data. If we have that scenario, and then in that case, you don't really need systems like Hadoop to store and process this data. You can still live with normal RDBMS system because you have a huge data, but then you are taking 1 year long time to accumulate that huge data. So that means it doesn't really you don't really need a system like Hadoop which can support such kind of which needs to support such kind of data growth. But in the first scenario where we are generating huge amount of data very rapidly, very fast, that that means we are basically needing a systems like Hadoop which can store and process this data efficiently. Okay. By the way, am I audible, everyone? Okay. Yes, Uday. Okay, so looks like one of the participant is not able to hear me, so that is the reason why I basically asked this question. But anyway, so I think I've just messaged him. He should take care of settings at his end. Uh, yes, Ishwar. So basically, you will get all these PPTs from the LMS, as I showed you right in the first session. It's the first few minutes. Basically, there will be a learning management system URL which will be sent across to your email. I guess it would have already been done by the SimplyLearn team. You would have received that email with a login credential. If not, you will receive it soon. So that URL you need to log in, and then you will find all the course materials in that way in this URL. Okay, you can go to each and every topic. Under that topic, you will have a materials PPTs for that topic. Okay, yeah, sure, no problem. Yeah, so let's come back. Yes, Uday. So I would also suggest a book, which I would anyway recommend to the people later on the sessions. I think it's too early to recommend this book, but anyway, it's fine. I'll just type it here. Hadoop Definitive Guide, 4th edition. Hadoop Definitive Guide 4th edition is a book name. You all can refer this book. It's a very, very good book related to Hadoop. If you want to have a thorough knowledge about Hadoop and its ecosystem, just go through this book. This is very, very interesting book. No need to learn any other books. This is enough. Okay. All right. Let's come back to the discussion what we were having. So I was just talking about velocity, and as we understood, velocity means the rate at which the data gets generated into your system. And for big data, you should have a high velocity also, so that you can use that and process that using Hadoop kind of system. Because RDBMS kind of systems cannot scale to support such kind of growth. Okay, that is about velocity. And the third dimension is variety. Variety means different types of data. So you can have data, any data can be, by the way, categorized into 3 buckets: structured data, unstructured data, and semi-structured data. So let us take an example of all these types. What is structured data? Structured data means any data which you can store in, let's say, table, rows, and column format. For example, any data which you are storing it in the RDBMS tables in the form of rows and columns by applying schema to that. That means it's a structured data. What is unstructured data? It's reverse the definition of structured data, which is you cannot impose any schema definition on top of the data. That means it's unstructured data. And the example could be log files, right? Every application generates huge logs. They are basically plain text, which is called unstructured data. Along with that, they are also generating data like audio files, video files, normal text. Like when we send email to our friends or colleagues, the email messages that we type, that is unstructured data. It's just plain text, but it is unstructured data, right? So these are the example of unstructured data. One of the simple example that I would like to share with you, which really helps you understand what do we mean by unstructured. So I'm sure everyone uses WhatsApp for communication messenger. So when we try to chat, when we basically use chat messenger like WhatsApp to chat with friends and colleagues, professional colleagues and relatives, let's say one of your friend's birthday is today and you want to wish him or her a happy birthday. You are saying happy birthday. One of the other common friends says many happy returns of the day. And the third person says, hey dude, you are growing 1 year older and I'm feeling sorry for you. So what I'm trying to highlight here is all these three different ways of wishing that person a happy birthday. As a person, definitely he will understand what others are trying to wish me. But if you look at the text that they are pasting, they are sending basically, these texts are completely different from each other, right? They don't really follow any structure. They don't really, it doesn't mean that there is no standard which is followed where it says that if there is a first word which is happy and the next word which is birthday, then only it means happy birthday, right? So basically for machine it becomes very difficult to predict the structure of the data here, right? Of course, there is a big science out there which is called text analytics, and people write a lot of interesting algorithms to analyze patterns within the text, and that's how they identify that these two text means the same. But at a high level, when we write this text, they are all plain unstructured data. Okay. So by the way, these are the examples of unstructured data, and then the third type of data is called semi-structured data, where the example could be XML file or JSON files. So in XML file, I'm sure many of you would have seen the XML file or work with XML. You store data in the form of parent and child tags. Basically, there will be tags, custom tags defined in the XML, and then you put values within that tags. Now, it may so happen that the tags will be having a hierarchical order. So that means there is some structure which is defined in between tags. But the value that you put within the tags can be anything, right? It can be any unstructured data. So that means it is having some amount of structured data and some amount of unstructured data, and that means it is not completely structured or completely unstructured data, and hence it is called semi-structured data. Okay. So basically, in a nutshell, if you have a huge volume of data which comes to your system very rapidly, very fast, that means it has a higher velocity, and it can be of any type of data, structured, unstructured, or semi-structured data, then we call it as a big data. So that was a formal definition given by IBM. Okay. On top of that, recently this definition has been enhanced, and I'm going to actually talk about that as well, which is let me introduce two more V's. So basically they have introduced two more V's to this definition. One is called veracity, and then one is called value. So what is veracity? These are the two V's which are recently being added into this definition by the data science community. The standard definition still follows the three V's, but these people have added two more V's to this definition. So what is veracity? Veracity stands for correctness of the data. For example, let us understand. Let me give you one real world scenario which will help you to understand the veracity. So veracity means, I mean, let's take that scenario first. So I'm sure everyone has heard that Facebook has bought WhatsApp, right, for about $19 billion. So anybody knows why Facebook has paid so much money to WhatsApp? Does anyone know why they have paid huge money to WhatsApp to purchase WhatsApp? What was the reason behind that? Yes, Vijay?
Is it because of all the data that WhatsApp has from all the different people?
That's absolutely right. Yes. Thank you. And thanks everyone else as well. I think many of you have given the right answer, which is basically the user base, the contact information, the user details. Thanks, Raj, Shanu, for this answer. So basically, yes, WhatsApp had billions of registered users, and everybody is logged into WhatsApp using their phone numbers, right? So, and they are registered to WhatsApp. So there are a lot of information related to users which are being already available with WhatsApp. On top of that, every user is basically doing a lot of activities on WhatsApp. These days many people are also running their businesses on WhatsApp. They basically talk or share a lot of information about their business with their professional colleagues over WhatsApp. A lot of startups do that. So that is the reason there are a lot of valuable information, wealth of information available on these chat messages, which is important to analyze. And that's why Facebook paid them huge money so that they can access this data. Okay. Now, for example, let's say Facebook wanted to do a sentiment analysis between two users. They wanted to understand how users will react in different situations, right? Definitely, when we talk to friends and relatives, we'll share different emotions based on certain talks, certain messages. So they wanted to analyze, let's say, one such use case. So they need to analyze the chat messages between two users. Now, it is possible that, see, all of us, when we talk to our friends or let's say relatives or professional colleagues, the way we talk to different people differs a lot, right? Depends on how we are related with that person. If I'm talking to my friend, my language of communication will be very, very different than if I'm talking to my professional colleague, right? Then I will use proper English, and there will be a professional English which has to be used when you're talking about work. But then when you're talking about your friends or your relatives, then of course you will like to use a language which is more native to you, right? It could be a local language, it could be running English, it could be anything. So what I'm trying to highlight is people use different language to communicate with different people based on what they are trying to do with this. So here what I'm trying to highlight a point is everybody use different languages. Everybody basically to communicate over a WhatsApp. Now it may possible that when you're talking to some friends or relatives, You may use a lot of slang words, lot of shortcut words, or you may not use a proper dictionary meaning words. So if you are using that many too many of such words, then it becomes very difficult to analyze the data, right? As long as if you are using a dictionary meaning, then it's fine. But the moment you use all this slang words, then it becomes difficult to analyze the data. And for that, if you have so much of such kind of words which are mentioned in your text, like a lot of F words and all that, then it becomes difficult for machine to predict that data. And that's where basically machine cannot give you right predictions if you have so much of such data. So these words are called noisy words in the data science terminology. And basically it is important to make sure that you have less amount of such noisy words in your data to basically be able to do any kind of predictions on top of this data. So even if you write very good algorithms, it's very difficult to basically I would say predict any interesting information out of it unless you have removed those noisy words from your data. So basically, there is a step in data science activity which is called data cleansing, where they remove this data to basically make sure that algorithms will be fed with only proper word or proper data. Okay, so that's about veracity. So degree of noisy words should be very less in your data. That is what we mean by veracity. So it doesn't mean that you have huge data and it has high velocity and variety. We just, that data is valuable to us and we start analyzing it. There is also very important point which we need to look is which is called veracity, which is called degree of accuracy or correctness with the data. So if you have too much of junk and garbage data available, then it will not make sense to supply to algorithm, right? So you need to first clean up that. You need to make sure that proper meaningful information is only available which you can analyze it. So that's about veracity. And the fifth part is value. Value stands for, the business value. What is in it for me? What kind of values I would get by basically analyzing this data. All right. So value stands for it's for the people who want to invest it in the projects, big data projects. They wanted to understand what kind of value it fetches for me by analyzing this data. So this is where data scientist comes into picture. They are the ones who are experts in domain as well as technical knowledge of machine learning and everything, and they basically understand your data. They try to come up with interesting problem statements, and then they try to do a lot of of course R&D type of work to basically help you understand that these kind of solutions would really help you to gain more profit in the market because they have done that market study as well. So that's the value dimension, which is more abstract parameter for the business point of view. What is the business value out of this? So in a nutshell, all these 5 V's together will form a big data. Okay. So this is the definition of big data. Is everyone clear with the big data definition? So Mary, value means it's a business value basically. What is in it for me? What kind of profit it would provide you by analyzing this data? So when you want to really invest in some projects, what kind of use case I should be solving with this data so that I can get great returns out of it? That is what we mean by value. And the value part is more the materialized when you have a right amount of data, right? That is where basically you will be able to analyze it and you will be able to generate some interesting use case. So that's where data scientist comes into picture. who will help you to and decide the value of a particular use case. Basically, they'll come up with interesting use case and they'll tell that yes, this data is valuable to be used in this, and then once you analyze it, you will certainly get good profits out of it. So then people start, top management will start investing into these projects. Okay. All right. I'm getting some requests from different people about the, they just wanted to check whether they are able to speak up or not. So I think let's do one thing. I'll just spend quick 2 to 3 minutes. What I'll do is I'll unmute people one by one just to make sure they are able to hear me or not. Okay. They are able to speak up or also not, right? So that everybody is be rest assured that yes, they can speak up whenever they want. Okay, I'll just spend 2 minutes on that. Let me unmute one by one people so that they will know that yes, they can speak up, and whenever they want to use mic, they can do that. I'll go ahead with some of the people in my list. I'll unmute Shiva. Hey Shiva, can you hear me?
Yeah, I can.
Okay, great. Thank you. So Shiva, you know how to ask questions, right?
Yeah, usually I can ask questions through the chat, right?
Yes, absolutely right. Yeah, that is one way. I'm just saying that in case if you want to use a mic anytime, right? Then you can always raise a hand and I will unmute you. All right?
Okay, yeah.
Thank you. Uday, I have already tried. Vijay, I have tried. Yeah. Mary?
Yeah, hi. I'm able to hear you.
Okay. All right, great. Thank you. Aisha? Aisha, can you hear me?
Yeah.
Okay, thank you. Yes, Divakaran?
Hello, sir. Yeah.
All right, thank you. Hey, Ishwar, can you hear me? Ishwar, can you hear me? Okay, so maybe I'm really sorry. I think your name is Ishwar or Kishwar because you have written, these two names. So I just wanted to make sure I'm pronouncing the right name. So let me know through chat window in case if you don't have a good mic setting. Looks like I'm not able to hear you, so maybe there is an issue with your mic. So what I would request you is just type it in the chat window, okay, whenever you have any doubts. Hi, Mano. Can you hear me?
I'm good.
What's your name, by the way? What should I tell you?
Manu.
Mano. Okay, great. Thank you. Hey, Nikhil, can you hear me? Hello.
Can you hear me, Jeremy?
Yes, you are audible. Thank you. Raj, can you hear me?
I can hear you.
All right, thank you. Shanu?
It's Shantanu. I can hear you.
Okay, thanks, Shantanu. Your name is, your email ID says Shanu, that's why I just spoke it. It's fine, yeah. Thanks, Shantanu. And hi, Vishal. Can you hear me?
Yeah, hi, I can hear you.
Okay, great. Thank you. Great. So I think we have checked with all the people in our attendee list. Let me know, please, if I have missed anyone. So looks like everybody is able to hear me except Kishore. So Ishwar, I probably am assuming that you are at least able to hear me, and maybe you're not. I'm not able to hear you because maybe your mic issues. But then you can always type it in the chat window if you have any questions. All right. So feel free to everyone to use chat window as in when you have any questions. In case if you want to, use mic, then you can raise your hand and let me know. I'll unmute you. All right. Great. So let's move forward. So that's the big data definitions that we wanted to cover. Now what we will do is we will basically start with some interesting case studies with respect to big data. Okay. So we will basically understand why big data. What was the reason why big data is so much popular, and what kind of case studies are being solved, what kind of problems are being solved by different industries using big data technologies. Okay, so as you can see, the need for big data is 90% of the data in the world today has been created in last few years, right? And some more majority of the data is unstructured. Structured data is also there for a larger number, of course. And then it is difficult to integrate the information distributed across multiple systems. Most business users do not know what should be analyzed. Potentially valuable data is dormant or discarded, right? It is too expensive to justify the integration of large volume of unstructured data. And of course, a lot more reasons like that. So basically, there are data which is being generated from various sources, like for example, weblog, sensor data, social media, internet, search index data, atmospheric science, scientific data, and photographic archives, and lot more. So basically, there are lot of sources through which you are generating data. And of course, the data is growing very rapidly, very fast. The world is experiencing a data growth heavily on a year-on-year basis. So basically, we have tremendous amount of information which is being accumulated. So a lot of companies have actually thought that this is a good time. For example, let me just open a whiteboard and I'll just share a few details on that. So we'll be using also whiteboard a lot in our sessions. I'll be sharing a lot of details which are not there in PPT as well by using this whiteboard so that you will get more clarity on different topics. So this is a time range x-axis, which is basically nothing but it is like 1990s, 95, 99, 2000, 2005, 2005, 2007 time frame, 10 time frame, 2015, 20, and so on and so forth. So basically, as you can see, the date, this is a data volume growth, and this is the time axis, time range, a year basis. So there was one case study where they have published this graph which says that till late 1990s or till early 2000s, the data volume was very less. But from early 2000 onwards till the recent years, the data volume has been growing exponentially, right? It is called hockey stick growth in the business terminology, right? And the reason for this kind of heavy growth is because of the internet being the primary driver. Everybody uses internet these days to do a lot of activities through different gadgets like laptops, tablets, smartphones, and whatnot. Through them, they are always connected over internet and they are doing a lot of activities. Now, with that, they are adding up to the volume of the overall, digital world. Basically, they are adding the data to the overall digital world data volume growth. And stat says that the data growth was 62% last year, and it will grow to 1.2 zettabyte this year. So that's the kind of data growth we are expecting year-on-year basis. That means there is a tremendous huge information which is being generated every day. So this space, a lot of people have actually found this space as an opportunity, because the data growth was happening. So a lot of companies have started thinking that let us do something in this space. Let us start analyzing the data in this space so that we can remain competitive and do some interesting products out of it, so that we can gain advantage over the competitors. So that is one of the major drivers towards big data. That's where all these big data trends have started. That's where all the companies have started looking into the data and doing some predictions out of it, or doing some analysis out of it. Okay, so this was the reason behind the big data growth. Apart from that, let us also understand some of the interesting case studies. Okay, which is this. So as you can see from this slide, I have some important case studies which are listed here. I'll be walking you through some interesting case studies. I'll not cover each and every one, right? But this is just for your information. But let us try to still spend few more minutes and understand some interesting case studies which are used by different companies. For example, let us start with. So I'll be taking case study from social media, the healthcare and life sciences, right? Then, of course, the communication industry, the finance industry, retail sectors, the online sectors, and whatnot. So basically, different companies are using that for different reasons. Even this airline industry. So let us take use cases from this and then try to understand how they are using big data to solve some interesting problems. So here, basically, let's start with first use case, which is Facebook. I'm sure everyone is doing a lot of work on Facebook on a daily basis. So Facebook is one of the social media where it has billions of registered people from US, from India, from different countries. So they have published one study which says that there are about millions of registered users just from US, and if all of these users are registered, let's say all of them who are registered users of Facebook from US, all of them let's say they log into Facebook at this point, then from this point to the next 20 minutes of time, they will be doing a lot of activities like event shared, friend request accepting, photos uploading, messaging, posting the messages, joining the groups, or uploading photos, videos, all this. So what I'm saying is basically with these kind of activities, they are generating tremendous amount of data. So Facebook generates almost a terabyte of data almost every day, which is why it makes it as a huge data source for big data. Okay. Now, how does they generate revenue? So does anyone know like what is the revenue model for Facebook? Yes, very good, Vishal. So, yeah, thanks Raj and Mano as well. So yes, basically, and of course Shantanu. So they have given us the correct answer. The advertisement is the right answer. Of course, there are other revenue streams as well for Facebook, but advertisement is one of the very important revenue streams. So let me spend 2 minutes on explaining how do they materialize revenues through advertisements. So there are two types of advertisements prevalent in the market. One is called mass advertisement. The example could be, let's say we all watch televisions at home, right? We are all watching televisions. We are all basically, let's say a person sitting in Bangalore and maybe person sitting in, let's say, US, both are watching the television, both are trying to watch, let's say, a cricket match, which is happening live. And if there is an advertisement which comes in between this cricket match, both of them have to see that ad, right? So that means the user don't have control whether to switch off the ad or not. They have to see the ad unless they switch off the channel. That is called mass advertisement, where advertisement companies don't really care whether user is interested to view this ad or not. They just broadcast it to the mass set of users. That is called mass advertisement. What Facebook has done, it has done something called targeted advertisement with the help of big data technologies. So every user is registered on a Facebook. Every user is doing a lot of activities on Facebook. So Facebook track all the users' activity and his data, his profile data, and they analyze this data, do some sentiment analysis, and using some interesting algorithms and identify what are the likes and dislikes of this user. Right, and based on his interest level or her interest level, Facebook sends them the or should display them the advertisement on their Facebook page. Okay, so every user will see the ads on their page, which is very different from other users, because the way you are doing activities on Facebook, Facebook will show you the ads which are relevant to that. For example, if a person who is very much interested in sports, doing a lot of sports activities, uploading sports videos, joining sports groups, then Facebook will think that let me show him an ad of sports. So that he can go and purchase some products from that. For example, there is an IPL match which is happening in, let's say, Bangalore, and this user is staying in Bangalore. So let me show him an ad of that IPL match. He can probably click and buy the tickets of this match. He would be more interested to do that rather than a person who is not at all interested in sports, right? So this is called targeted advertisement. By analyzing users activity, you predict his interest level, and based on that you show him the ads of his interest areas. Now chances of that will be like users, if you have shown the ads which are of their interest area, they would click on this ad and they would basically go to the page and probably end up doing a transaction. So how does this materialize to the revenue? Like if you just click on the ad on your Facebook page, Facebook gets a revenue just by clicking in it. If you don't do anything after that, still Facebook generates a revenue. If there are 1 billion users and everybody makes 1 clicks, there will be 1 billion clicks, right? So it's a massive revenue that Facebook generates if everybody makes clicks on the advertisement shown on their page. Similarly, if you click on the ad and then go to the page and then end up doing some transaction, then Facebook gets a major share of revenue. So basically, there are various revenue models that Facebook has tied up with advertisement companies, but with all this, Facebook generates huge money, right? So it is very important for Facebook to analyze your data properly so that they will show you the right set of ads which keeps you interested in them, right? And that is where, to do this analysis, Facebook uses big data technologies. They have in-house Hadoop clusters, heavy Hadoop clusters available, where they run those machine learning algorithms on top of that to do this analysis and to analyze the data. So that's the case study where Facebook use big data technologies heavily. Similar to that, even Twitter uses big data technologies heavily to do the similar analysis on the tweets generated by people, right, and forms the interested group of people in a particular area. So they are also doing a similar analysis by identifying the tweets. Okay, now let's take example of some other industry, which is, let's say, a retail, or let's say e-commerce companies. For example, all the e-commerce companies like eBay, Amazon, or Flipkart, I'm sure you are aware of all this, and I'm sure you will be doing a lot of online shopping with these companies. So when you do any online shopping, the next time, let's say when you log into that website, for example Amazon, you have done some purchases of books, and the next time when you log into the website, which is Amazon, and you can see that there will be a section in the page which says these are the products which are recommended for you. Yes. So basically what it is showing, it is basically showing you that these products you would be interested to buy because we have analyzed that you have done similar transaction in the past, right? And based on your past transaction patterns, we are recommending you these products. even if you have not done any transaction earlier, and if you have just viewed some couple of products, then also it will show you the similar kind of products in the next in the recommended section. So they will also analyze how you have arrived, how you have clicked on and arrived to that particular product page. So they will remember your clickstream data. That is called clickstream analysis. And based on that, they recommend you these products, right? So this use case is called recommendation engine. And the stat says that 60 to 70% is a hit ratio. Basically, if I show you the recommended section products in the recommended sections, the chances are you would end up buying this product 6 out of 10 times. That is the hit ratio, which is a very good hit ratio, and it is called passive marketing. So they are using big data technology to come up with interesting recommendation products. Hey, everyone, can you hear me now? Okay, sure, yeah. So let us continue. Yeah, so I was just mentioning about the use case with respect to recommendation. So that is how basically they increase the sales by 60 to 70% by doing passive marketing, right? That is called recommendation engine. And this recommendation engine is one area in machine learning where they use a lot of interesting algorithms like collaborative filtering, support vector machines, decision tree. All these algorithms will help you to do recommendations. Okay, so the companies like e-commerce companies use recommendations a lot of time to basically sell their products to the users based on their past transaction patterns. Along with that, even the companies like YouTube, for example, are also doing recommendations. I'm sure you would have seen many times that when you log into YouTube and if you are watching some videos, next time if you log into the YouTube, it will show you a very similar videos which you have seen earlier. Okay, so this is called recommendations, and with that YouTube will improve the user experience. User does not need to go and search the videos. He can easily get it from that recommendation sections. That will improve the user experience with the YouTube, right? User keeps coming back to YouTube. It is very important that user keeps getting engaged with YouTube, because that's how YouTube makes some money, right? Because if you keep on watching the videos, there will be advertisements, through that YouTube makes money. So that's how basically there are different revenue streams, of course, but this is the one of the technique called recommendations through which they improve their business, and that will be achieved using big data technologies. Okay, let's take one more example from other industry sector like telecom sector. Telecommunication is also one more industry where big data is heavily used. For example, telecom sectors, telecom companies like in India you have Airtel, Vodafone. In US you have AT&T, T-Mobile. These are very big telecom giants. So I'm sure you would have done this at least once in your career, which is you basically you have shifted your services from Airtel to Vodafone or vice versa. So whenever you are doing this, whenever you are basically shifting your you know uh, telecom network from one company to another, you will get a customer care call from that company. They wanted to basically understand what is the reason why you are leaving them, right? And it will tell you that, I mean, you will definitely give them the feedback or the reason why you are leaving them. And these feedbacks are recorded in-house in their system. So these companies will have Hadoop clusters set up in-house where they record your feedbacks, and then they write MapReduce programs to identify how many users are are leaving or have left in the last one quarter for these many topics or these many feedbacks. So basically they can solve this problem by writing a MapReduce program that give me the top 10 feedback why majority of my customers have left me in the last quarter. This is called customer churn, and you are trying to prevent the customer churn by identifying the right reasons, right pain points. Once you know that, as a business you can come up with better competitive offers, right? You can actually give the better offers to the users. You can tell them some some offers like the current package, I'm reducing your price or whatever. So there could be many different ways to solve these problems, and with that they are making sure that their customers will not leave them and will stay with them. This is called customer churn preventions, and these companies are using big data technologies to basically solve that problem. Okay. Apart from that, even the call data record analysis is one more use case in telecom sector where big data is used. I'm sure whenever you would have experienced this, whenever you call to the customer care of any company, you will basically get to hear that this call is being recorded for quality purpose. So they actually do that. They actually record your call for quality purpose because they wanted to identify uh, how a customer care executive is giving you a service. So they do this audio analysis of the data, and based on that they will give feedback to their customer care executives. That is more to basically do with training. They train your customer care executives so that they'll improve their services to the customers. Okay, so that's about telecom sectors. Let's talk about healthcare sector. Healthcare sector is also using big data very heavily. They are basically using it to solve interesting problems. For example, let's say these days, I'm sure all of you have heard about Ebola virus, which was very deadly virus, which was there, and a lot of people have been unfortunately impacted with that disease. So let's say there was one study published by U.S. Healthcare Organization. They have said that uh, uh, they had a scenario or problem statement where they wanted to predict how many people from US or from New York City are actually impacted with Ebola virus, and they wanted to solve this use case. So basically they could not ask each and every individual of that city to go and have the test done, right? That is not practically possible. So what they have done, they have used this data science technologies, which is called classification, to solve this problem. So classification, I mean, to do classification, what they have done, they have taken a random sample set of people, that is called sampling technique, and they asked them to go for a test, about 1,000 people. Everyone, let's say, went for a test, the results are out. Now they know that people who are impacted with Ebola and who are not, both of these patients' data are available with us. right? In case if someone has a Ebola, what kind of medical health condition that person is having, what are the other medical parameters he is having. Similarly, person who's not impacted with Ebola, what are the values of other medical parameters for that person. So all these details, once they know, they supply it to the algorithm that they have written, which is called classification algorithm, which will basically start building a model out of it. Now, once the algorithm has actually built a model, then what they do is they now basically supply all the populations of New York City data to this algorithm. Right. So in US at least people are having insurance and they are basically connected to healthcare, so they'll have unique ID and everything. So basically their data is definitely there with healthcare insurance companies, and these healthcare organizations will tie up with these insurance companies, purchase your data, which will have some old medical records. So based on that, they will try to they get this data and they basically send it to this algorithm. So algorithm will now predict based on the past learning that whether you will be having or you are impacted with Ebola or not based on your, whatever medical parameters. So that is one technique called classification where they are using big data technologies heavily, right, in the healthcare organization. Same way you have, stock exchanges. You know what is stock exchanges? In the stock exchange also they are basically using big data heavily. Stock exchange is generated 1 terabyte of data almost every day. So it's a massive amount of data being generated. Now let's say someone wants to predict the value of the stock. What will be the value of the stock tomorrow? Or let's say today or any time. So there are companies out there who are expert in writing this stock prediction logic. The technique to do that is called high frequency trading algorithms, which will help you to basically predict the value of the stock. Okay. Once you basically predict the value of the stock, of course, if it depends on the accuracy, people would like to use it more. So what many companies, many billionaires, what they do is they give money to these companies, and these companies will first analyze the data of the stock exchanges. They tap with stock exchanges, get the data, analyze it, and based on that, they predict whether you should buy this stock or not because it is going up or down, like that. So it can give you the suggestion, and these techniques is getting very popular these days in US, and it is also popular in India. India, it is not yet explored too much, but in US, people have started using this technique for stock investment. Okay, again, it uses internally big data technologies. So that's about stock exchanges. Government, by the way, one more reason to use big data. One more use case I would say where they have used big data. Indian government have used it for building a Aadhaar card like system. I'm sure everyone knows about Aadhaar card. It's a unique identity given to every individual citizens of this country. So Aadhaar card is completely written using Hadoop. Okay. Of course, there are other technologies also used, but they have written underlying framework they have used is called Hadoop. Okay. Apart from that, even so, U.S. government has used big data to do like fraud detection, cyber security, all that stuff. So even the government is using big data heavily. Along with that, they are doing a lot of such interesting stuff. So that's about government. And the last use case I want to cover from finance sector. Finance industry is also using big data very, very heavily. Like for example, banks. Banks use big data technologies heavily. So let's say as a user, you want to take a loan. You are basically holding an account with Citibank and Bank of America, and you want to take a loan from, let's say, Chase Bank. So what do? You first go to this bank, let's say Chase Bank, and you tell that this is the loan I want, this is my years of tenure for this loan. Now, what banks does is, banks will first identify all your income pattern and spending pattern from your past transactions. So what they do, they first get all your transaction records from all the bank accounts wherever you are holding an account with. It's legal, by the way, for a bank to get all your transaction records from the other banks. And then they run analysis logic on top of this to identify what is his income pattern and what is his spending pattern. Once they know that, once they know the income and spending pattern, okay, they will basically identify easily that whether this user is able to save so much so that he'll be able to repay the EMI. So these analyses are done in this space to basically minimize the risk of giving the loans, because it may be possible that this person is likely to default. Then it is riskier to sanction him a loan because he will basically default, sorry. So that is why, to avoid that, they are doing this analysis over the data and identify whether this user will have a potential to repay the EMI back or not. Okay, so that's about finance sector. To minimize risk, they are using big data. So basically, these are all various areas where big data technologies is used by these different industry sectors to solve some interesting problems. So till now, we have seen these use cases to just realize the importance of big data. So till now, what we have answered is, we have answered what is big data and why it is important by understanding various case studies. So are we all clear as of now? Anybody has any questions as of now? All right. So let's move forward. Let us understand now the technology which can help us work with big data. So slowly we are moving towards the technology part of it. So we will start understanding about Hadoop. Okay. But before we do that, let me open a whiteboard and explain you the same diagram. As you can see, till earlier case, we never had a scenario where, see, if you can observe this diagram from this chart, we can see that till late 1990s or early 2000, we never had a scenario where we had a challenges in terms of storing data, because the data volume was very less. So people never had this problem of storing the data in a distributed manner or in more than one machine. They were able to easily use one machine to store all the data. But over the years, like from early 2000 onwards, when the data volume has been growing exponentially, then people had a challenges, not in terms of only storing the data, but also in terms of processing the data. So this is the space where people had now challenges about how do we handle this heavy growth of data, right? So this cannot be definitely fitted into a single machine. So they had a need to store this into more than one machines, and that's where they started using a technology called distributed file system. Okay, So let me spend 2 minutes on explaining you what is distributed file system. All right, and we'll understand the importance of it. By the way, distributed file system, the reason why we are understanding distributed file system because Hadoop is also internally going to use a distributed file system which is called HDFS, Hadoop Distributed File System. And that is why, we are going to first give you an idea, a conceptual idea on what is DFS, why DFS, and then we'll move towards the next topics. So let us understand what is DFS. So let me give you two scenarios. Okay, let's say I have one machine, and that machine has 4 I/O channels. And let's say 100 Mbps per speed. Okay, I'll repeat. So we have 4 I/O channels, 4 hard disks, and each hard disk has 100 Mbps speed. So now in this physical machine, what if I'm storing 1 terabyte of data in the single physical machine? So if I want to read 1 terabyte of data from this machine, how much time it is going to take? So there is a formula available, and if you put these parameters like 4 I/O channel, 100 Mbps speed, then it will give you the result. But let's not worry about the formula. If you read 1 terabyte from this machine using these parameters with these configurations, if you want to read 1 terabyte from single machine, then it is going to take approximately 45 minutes of time, which is very huge. Okay, that is definitely not acceptable because it takes a lot of time to read just 1 terabyte of data, right? And that's where to basically improve this efficiency, they have come up with a concept where now they have more than one machines where you can store this data in a distributed manner. Okay, assume that I'm just drawing some couple of boxes, let's say 10 boxes, and each of them will have the same configuration, 4 I/O channel and 100 Mbps speed. But now what I'm doing, I am dividing, when I'm storing this 1 terabyte of data, this time I'm actually storing it into multiple machines. Okay, basically I'm distributing the data, some part I'm storing here, some here, some here, some here, some part here, some part here, and so on and so forth. So what I'm doing here, basically I'm actually dividing my 1 terabyte of data into a smaller buckets, right? So I'm basically distributing my data into different machines. Now here, if I want to read 1 terabyte of data from these machines, I can do this. I can read parallelly all the parts of this file parallelly from this machine. So that means basically reading speed will be improved, right? Reading time, because you are reading parallelly this time. So how much time it is going to take to read from 10 machines parallelly? So earlier from one machine it was taking 45 minutes. Now it would take 4.5 minutes. And that is the level of performance we are talking about with the help of distributed file system. So now we are improving the efficiency almost 10 times by having a parallel processing of the data, right? Because we have stored data in a distributed manner. This was the fundamental advantage which was given by distributed file system. There are many more advantages to that, but this is a fundamental reason why distributed file system came into existence. All right, so that's about why distributed file system. Is everyone clear with this? Any doubts on this? Yes, Nathan, of course, you are right. So I'll be explaining you now what is distributed file system. So Nathan, your question will also be answered there. So let us understand what do we mean by distributed file system exactly. Okay. So let's say I have 4 physical machines which are being, let's say, shown like this. And these 4 physical machines are, let's say, they are connected over a network. Okay, so I have 4 physical machines and they are connected over a network. All right. Now, everyone understands the local or physical file system, right? See, every physical machine, even if your laptop for that matter, will have some system called local file system. Okay, and if you look at that, this local file system would basically have uh, all your files and folders stored. So for example, if you are using a Windows, you will have C drive, D drive, where you can store all your files and folders. This is your physical file system. Even for that matter, Linux users or Mac users will have a Linux kind of file systems like /user/home. Then you put your directories and store the files. So basically, these are all we refer them as actual physical file system. So every machine will have its own physical file system. These are 4 machines, so all of them are having their own physical file system. But what do we mean by distributed file system? Where does that appear? So whenever you want to install or configure a distributed file system, you need to first understand that distributed file system is not physical, it is virtual file system. Okay, and we have dedicated programs which are running, which makes up the distributed file system. So what we need to highlight here is we are going to install some programs. Let me just show it in a different color. So we are basically going to install these programs which are running in this red color in every machine. Okay. So with that, it is going to form one virtual layer which comprises of all these physical machines which are connected over a network. Okay, this layer is referred as a distributed file system. So what happens, let's say for example, if there is a file of, let's say, 1 terabyte of size and I want to store this file into DFS. So as a user, what we need to do, we are going to use some distributed file system command. For example, you will say something like this. If you want to store it, you will say DFS -copy. Let's not worry about the syntax right now. We'll learn about it later. But right now, assume that there is some command which copies the file from source location into the destination location. Okay. from source to the destination location. Now the destination location is the path which is called HDFS path. Okay. So here in the destination path, you can give any folder location. For example, under data directory, I want to create this file. Let's say file name is f.txt. So you are just creating f.txt. Okay, so in the destination path, I'm giving one path. This is a virtual file system path, the distributed path. That means this path does not present in any of this machine. Remember that very carefully. It is just a virtual path. That means it's a metadata. So whenever you are asking it to copy your file, which is 1 terabyte, into this path, we as a user think that we are going to store entire 1 terabyte into this location under a single physical machine. But behind the scenes, what happens when you execute this command, these programs which I have highlighted here, which are running in different machines, they become active, and they are basically going to divide your data into the multiple parts. And these parts will be stored in the different physical machines, A, B, C, D, in the local file system of these machines. But as a user, we are not aware of that. We think that everything is stored under this path. But behind the scenes, your file is distributed into these many machines, which is not, which we don't know. Now, if you want to read the file, you think that you have stored entire file under this location, so you will just give that path, dfs-cat. Cat is a command to view the contents of the file under this directory, data/f.txt. Okay, so again, when you execute this command to read the data from this path, we as a user think that we are going to read it everything entire 1 terabyte from this path from the single machine. But behind the scenes, what happens? It again, these programs who have divided your file into different parts, they know that this file is divided into multiple parts, and they are basically going to read all these parts from these machines and then present the data to the user. Okay, so that's how reading happens behind the scenes. Okay, so that is what we mean by a distributed file system. We will understand a lot more in detail about DFS when we cover HDFS architecture, where you will get a lot of details and a lot of thorough knowledge. I'll be covering one architecture which is not there in the Simply Run PPT also, which will really give you a very good understanding on HDFS architecture. But that we will cover in the next sessions. So this is just a high-level overview that I'm giving you on what is DFS. Okay. So is everyone clear with that? Okay, Uday has a question. Is it really feasible to read 1 terabyte of data? Uday, good point. It is definitely not feasible to read 1 terabyte into memory, but when you do distributed processing, you process it on a different nodes itself, and then results are combined, right? So, but the technique is this only. You go to different parts, you process them while reading it, and then whatever is the result, you are basically transferring it to the machine, which is accessing that, to the client basically, okay? We are going to see how processing works in the HDFS. Yes, Uday. These 4 parts, that means 4 sub-files, are physically distributed into the 4 machines. So is everyone clear? Anybody has any more questions? Raj, we will talk about this in detail when we have any when we go through we'll slowly go towards that topic. It's a very good observation you have. What if one machine goes down? But let's go step by step. We will definitely cover it in some time. No, Nitin, it is still important to have one more layer above that, because you are going to use different resources in a distributed manner, even though everything is in the same stack, right? So it's important to have one more layer above them, because that layer, which is a DFS, which is a virtual layer, which gives you the capability to process your data in a distributed manner by leveraging these resources differently in parallelly. The whole idea of using distributed file system so that you can process the data parallelly. If I want to, let's say, read this data from this file or process this data of 1 terabyte, if I store it in the entire file as one file in one of the machine, then I would take a lot of time to process it. But since I have stored it into multiple physical parts, now I can process individual parts parallelly, and then definitely there are ways to combine the output and again process it, and that is the whole approach we are going to learn in MapReduce. But what I'm trying to highlight a point is, in this approach we are going to process all the parts of the file in a parallel manner. So we achieve parallel processing, by the way. Okay. Okay, does anyone have any more questions on this? So we have just introduced a DFS because we are going towards Hadoop. So we need to understand what is DFS, what are the advantages of DFS, what does it really help us achieve. So we have just given a basic idea on what is DFS and why DFS. Now we will also slowly start understanding the motivation for Hadoop, like why Hadoop has been chosen as an effective technology to work with big data. Okay, that is what we are going to learn. So I want to understand this, like, does anyone has any more questions, or we are all good as of now? Yes, Shiva. Data will always be distributed in different parts, different parts which I have shown here, right? A, B, C, D. So your file is always distributed. That means your data is also distributed in this part physically, right? And that is what we are going to learn in the overall architecture, like how your data will be processing the files. I mean, how do you distribute the data first into different files? Then how do you process it? How do you read the data? These are the important architectures which we are going to understand. And I will also give you some details about the architectures which are not there in PPT, so that you'll get clarity on that as well. Okay, so now what we'll do is we'll go ahead with the new topic, which is motivation for Hadoop, like what kind of benefits Hadoop provides over the traditional systems. And again, we'll understand it at a high level first, and then we'll make a deep dive into that. Okay, so I think so every session, by the way, this is something that I wanted to tell you, that every session will have a break time. So we'll take a break almost this time, during this time only. So we'll take 15 to 20 minutes break, and then we'll come back and we'll continue the session. Okay. So we'll always have a logical breaks as and when we complete one topic, and then we'll move forward with that. So let's take break 15 to 20 minutes, and we'll come back. Is that fine with everyone? All right. So see you all after the break. Hello, are we all back? Okay, so let's get started. So we have actually understood the basics of big data. We understood how what is big data, and how different companies are using big data to solve some interesting problems. Now we'll start with understanding more on the technology side of it, like which are the technologies, what all advantages we'll get by using Hadoop over different technologies, and why Hadoop is a better choice. So before we started with Hadoop, we also understood the basics on distributed file system. We understood what is DFS and why the DFS is used. So now let's do some whiteboarding and understand some advantages of Hadoop as well. Okay, great. So let me just draw the diagram. So any distributed file system, by the way, is following a master-slave architecture. For example, this is my master node, and these are all slave nodes. Okay, so all these 5 machines together forms one cluster. So from now onwards, we refer the cluster as 5 machines together, and we refer every machine as one node. Okay, every physical machine is referred as one node. So it's a cluster of node. So here in this architecture, there are 5 different nodes. That means 5 different physical machines available, which are interconnected over a network. So it's a cluster of 5 physical machines or 5 nodes. All right. Now here, so does that answer your question, Uday? Okay. Now this is your file. Let's assume the file was there, and we understood that when we store file, it would be divided into multiple physical blocks in SDFS. Okay. And it would be stored in the multiple slave machines. That is what we understood, right? Apart from that, see, the slave machines are the ones which will store the actual data. Hi, can you hear me, everyone? Okay, all right. Okay, so let me continue. So I was just saying that this is the file where I was dividing the file into multiple blocks, multiple parts, and they are stored in the slave machines. And in the master will store the metadata mapping. For example, let's say the file name is F. So the file is stored in how many blocks? Okay, and which part of the file is stored with which machine. So here if you see machine 1, 2, 3, 4 available. So A is with machine 1, B is with machine 2, C is with machine 3, and so on and so forth, right? So basically the master will help you decide, I mean, it will basically store the metadata mapping information, like which file is divided into how many blocks and which block is stored in which all slave machines. That information is present at a master level. Master does not store actual data, it stores only the metadata information. Okay, and the slave stores the actual data. Now this is with any normal distributed file system, this is valid. Now let us understand some important advantages to that. For example, let's assume that one of the machine goes down in this cluster. If one of the node goes down in this cluster, then what happens? I will lose the part B of this file. So for example, if there is a client who wants to read the data from this SDFS, he will always go via name node. Why? Because name node, basically he will always go via master node. So master is the only one who will remember the mapping information about that file. How many parts are stored in for this file and which part is located in which machine. So client will have to go via master to read this file. Now, if your one of the machine is down, master cannot give him a data of part B because that is not available, right? That means client cannot read this complete file, which is not a correct scenario, right? You should never have a data loss when you are storing data in a distributed system. You need to make sure the system guarantees you the high availability of the data. So to avoid this kind of situation and failures, there is a concept called replication. Okay, replication. I'm sorry. So basically, every system will be expecting you to configure a replication factor. Let's say you define replication factor as 2, which means every part of the file will be replicated 2 times. Like part A will be here, B will be here, C and D will also be replicated in this manner. Okay. When I say replication as 2, that means every part of each file will be replicated 2 times, will be created 2 copies and stored in different machines. Now here in this situation, even if I have machine 2 which failed, still if a client wants to read a file, I can have part B available with some other machine and I can read the complete file even if there is any failure in the system, right? This is how we can achieve high availability of the data. Okay, so that is one way you achieve the high availability of the data. But the traditional distributed systems, like for example any RDBMS or Teradata or any data warehouse systems, were not able to give you 100% reliability in terms of retrieving a data compared to Hadoop. Hadoop definitely give you 100% reliability. So let us understand that little bit. The same concept which we talked, I'll explain you a little bit more in detail. So Uday, I think it's a question which we will cover in the next session. We have to wait till that point. Who and how it is decided which part will go to which machine? Of course, it's a very valid question, but we will understand this architecture in detail, as I said, anatomy of a file write or SDFS architecture. Basically, how data gets written into your distributed file system. In that itself, we will understand how master decides which data should go to which node and how does it maintain replication. Everything we will cover there. Okay. Mary, it's a good observation. What if master goes down? If a master goes down, it becomes single point of failure. But in Hadoop latest version, they have given you option to configure more than one master, so that if active master goes down, the standby master will become active and start serving the cluster. So you will avoid single point of failure. What do you mean by single point of failure? Because master only remembers all the metadata mapping information, right? So if I want to access any data on the SDFS, I will have to go via master. But what if master itself is down? I don't have any way to access this data because the mapping information is only there with master. So that is why it becomes single point of failure in this cluster. Your cluster is unreachable. But in latest Hadoop versions, you can configure more than one master, through which you can have this master availability. Does that answer your question, Mary? Okay. Yeah, let's come back to the discussion that we were having. So let me just complete drawing this and then I'll explain what I'm doing here. So basically, I'm sure all of you have seen data center or command center in the companies where you are working, right? You would have certainly seen this command center or data center where you can see that they will be hosting a lot of racks, and each rack will be hosting a lot of application servers, a lot of appliances, right? So these boxes which I'm showing you are nothing but each of them are one machine, one physical machine which are hosted in a rack. Rack itself is one device. So there will be, let's say, machine 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the different, let's say there are 9 machines which are installed in 3 different racks, and they are all connected via outer switch so that they can have intercommunication, and they are also connected from the outer world through that switch. So this is a normal configuration of any cluster you will have. So for understanding purpose, we are seeing that this is how our cluster looks like, but actually your cluster will physically be deployed in this manner. This is how it will look like. Okay, so one of the machine will be a master machine. All others are slave machines. Okay. So now let's take a scenario here. The same file, I want to store it in this kind of cluster with the replication factor as 2. Now tell me one thing. What if I will store this one block part A? I have to store it in 2 times. So what if I store it in this fashion? Part B, part C, and part D. Do you see any problem if I store data in this fashion? Yes, very good, Vishal. So yes, Mano, that's correct. So basically here, yes, Uday, that's absolutely right. So basically what happens is if the rack goes down, I will lose all the data. Yes, Shantanu, that's right. So if any of the rack goes down, I will lose both the copy of the respective block which is stored in that rack, even though I have stored them in different machine. That is why, you still cannot guarantee the high availability of the data. And this is what was the limitation with traditional distributed system. Okay, they were storing data in this fashion which I have just shown you right now. They don't follow rack awareness. There is a policy which is called rack awareness, which is followed by Hadoop, and hence it will always guarantee high availability of the data, but other traditional systems don't follow it, hence they cannot guarantee high availability of the data if a rack fails. Okay, so in Hadoop case, what does it do? It will always make sure that two copies of the same block will be stored in two different racks, so that there, even if the rack fails, there will not be a risk of losing that data, because that data is available with other machine of other rack. Okay, so that is how it guarantees the high availability of the data. There are many more benefits to use rack awareness, which we will understand later, but this is just one critical important difference between Hadoop and traditional system, okay, in terms of high availability of the data. All right, so is everyone clear as of now? Okay, so now let's talk about other difference. One very important difference is in terms of processing the data. Okay, so there is a master and there is a slave machine. Now here, yeah, before we do that, let me just quickly draw that other information that the file is divided into multiple blocks. Yeah. Now let's say I have a file, this file which is divided, which is having 1 terabyte of size, and I have stored it in this fashion, which we understood earlier. Now let's say there is a client who wants to process this file. So client has submitted a program to the master machine. Okay, client wants to submit this file, process this file by submitting this program. It is actually, it wants to do the distributed processing. So in the traditional distributed system, how it used to happen, that is what we are going to understand. So in the traditional distributed system, when the program was submitted to the master process, what happens was master used to know, because of its mapping information, it used to know that with this file has how many blocks and where they are stored. So it used to bring all the data of this file, okay, to the machine where so just explaining that the data has been transferred over a network to the machine where the program is running. Right. So what happens here is it was following an approach which says the data is transferred over a network to the machine where program is running. That was the approach which was followed in the traditional distributed system. Now when that happens, all these parts are basically transferred over a network, and then the program will start processing the data, all this data, by combining it at one shot. Hello, can you hear me? Okay. So you can see all this screen, right? All right, great. Yeah, let me just repeat what I have just said. So basically, we have a scenario where client wants to process this file, okay, which is of 1 terabyte of size. The file has been distributed in this manner in these 4 slaves. Client submits a program to the master. Now in traditional distributed system, master used to bring all the data which a file want to process over a network to the machine where program is running, and then it will combine all the data here. Now what used to happen here, once all the data is combined here, then program is going to basically analyze all this data here and then give the output. So there are multiple challenges or I would say disadvantages which are there with this approach. First is you are basically transferring 1 terabyte of data over a network, right, to process this file, which means there are too many network bandwidth that is being consumed for transferring all this data over a network to the master machine. That is one point. The second point is you are bringing all the data to one machine and then you are trying to run program on top of that. So you need high-end resources to this machine to basically process this. Along with that, you are not actually leveraging the true distributed processing or parallel processing power, right? So these were some of the challenges that were there with traditional distributed system approach. What Hadoop has done is it has actually solved these problems by processing the data in a completely reverse way. So let us understand that of how Hadoop has done the processing. So when a client submits a program to process this data, what master does, instead of bringing data to the machine where program is running, now we are transferring program instance only to the machine where the data of this file is stored. So it is following a pattern where computation is sent to the machine where data is running. Okay, that was the approach followed by Hadoop. Now what happens? Every program's instance are created, right? P1, P2, P3, these are different instances of the program, and this program is going to process the data of part A, B, C and D parallelly. That means P1 will work on A, P2 will work on B, P3 will work on C and so forth, and all of them are going to generate their own intermediate output files here. Correct? All of them are going to generate their own intermediate output files. So that way basically you are actually achieving a parallel processing because you are trying to process all the parts of the file parallelly. That is what we mean by parallel processing. So with this approach, yes, we are actually doing a parallel processing. One more advantage is we don't really need to transfer all 1 terabyte of data over a network. We are just transferring program instance. So it's very small network bandwidth that we will use. So we are also saving a lot of network bandwidth here. And then once this instance have processed individual part of the file independently and generated the intermediate output files, that doesn't complete your processing because you need to still process all the file which is basically you need to still process all the data for the entire file set. So what happens here when the intermediate output is generated, right? What happens? It is basically trying to combine all the output files again. Okay, this data has been combined again and given to one of the machine where it will run one more process. The name of that process is called reducer, which will process this data to generate the final output. All right. Now, why do we need to do this combination? Because if there is some interdependency between this data which is stored in different parts, and if we are processing this part independently, of course we need to resolve that interdependency. For that only you are trying to combine all the intermediate output which is generated by all the machines in this fashion, and then giving it to the one of the process where it again process all the data one more time, so that if there is an interdependency which will be resolved and you will get a final output which is the actual output which you can use it for your whatever analysis purpose. All right. So this is how basically Hadoop is going to process the data. The pattern that I have explained you is called map reduce. Okay, and we are going to spend a lot of time in understanding MapReduce, writing a lot of programs, doing a lot of hands-on work on MapReduce. Okay, but this architecture has to be understood first very clearly, and we will have a dedicated session where we will understand this architecture very clearly. Okay, we'll not basically cover this architecture right now. I'll just give you an overview of this right now. So if you have any questions of what if one process fails, or what if one machine is not available when it is processing, how does it take care of failures, then they are all very valid questions, but we will not address it right now. We will address it when we have a thorough detailed architecture sessions discussion on the MapReduce. Okay, so as I said, we will have couple of more sessions planned where we discuss dedicatedly on the architecture of HDFS as well as MapReduce, so that we will have all our doubts clear. All right. So, but here the important point to notice in this point, example that I have given you is, with this kind of approach, MapReduce is going to process data 10 times faster than the traditional distributed systems, and that is why also Hadoop is chosen to be more effective technology to work with big data, because it gives you better performance over other systems. Okay, so what approach you are following here? You are following an approach called divide and conquer, which is the pattern which is used in many data structure algorithm like merge sort, quick sort, like that, right? So basically you have a bigger problem to solve, you divide it into smaller problems and then individually process each smaller task parallelly, generate the output, then combine that output, merge it, and then try to process it one more time to generate the final output. That is what we mean by divide and conquer, right? Parallel paradigm is map and reduce. Right, and in between there is a combination happens of the data which is called shuffle and sort. So there are three phases in your map reduce: map, which is a divide phase; reduce, which is a conquer phase; and shuffle and sort, which is nothing but you are combining this intermediate output from different machines, right, and then giving it to one more process which is called reducer. So that combination happens in this phase. Okay, and as I said, we will look into it more detail about every phase during the architecture discussion. But this is just to give you a difference between Hadoop and traditional systems, why Hadoop is better in terms of performance. Okay, so is everyone clear as of now? And does that answer your question, Nikhil? Hello, can you hear me? Yeah, I'm just asking you, like, are we all clear with this approach? Anybody has any questions? I was just on a mute. Just wanted to wait for people to respond. Okay, so Vishal, the intermediate output will be stored in the local file system of all of these slave machines. Okay, and the final output which is being generated by the last process, which is reducer, will be stored in SDFS. Okay, that's what we are going to understand, like how do we store data in SDFS. So when we execute MapReduce program, you have to give the output location, which will be an SDFS path. So that location, it is going to store your data. All right. All right, great. So let's continue and understand few more important advantages Hadoop provides. So Hadoop follow a principle which is called CAP principle. This is a master. These are all slaves. Now, as I said, Hadoop follows a principle which is called CAP principle. In fact, any distributed file system will follow that principle. Just give me 1 minute. Let me just draw that first and then I'll explain. So C stands for consistency, A stands for availability, and P stands for partition tolerance. Okay. So let us understand each one of them. By the way, any good distributed file system can support this CAP principle. That's a standard for any distributed file system. Okay. So I'll again repeat. C stands for consistency, A stands for availability, P stands for partition tolerance. Okay, let's understand each one of them. So what is C? C means consistency. Consistency means okay, before that, we were just understanding this part that the file has, there are multiple parts of the file and we are basically storing the parts in the distributed file system. So again, we understood that each part is replicated 2 times just to basically make sure you have high availability of the data. So A is availability. So if one machine goes down, you can still have that part available with other machine, right? That is what we mean by availability of the data. What is consistency? Consistency means, let's say there are 2 blocks which are block C, right? And let's say I'm going to change a data in one of the block from C to C dash. If I'm updating one of the block, one of the part which is from C to C dash, automatically the other replica copy of that block should also become changed. Okay, so this should also become C dash. That is what we mean by consistency, because if you don't change it, then what happens, you have a replica copy which is little old and the original copy has been updated. So client may get to read some inconsistent data if it reads from the replica copy, and that is why it is important that framework will take care of updating the replica copy as well. Okay, that is what we mean by consistency. That means consistency across all the replica copies. The third principle is called partition tolerance. Partition tolerance means basically whatever we have learned for distributed file system, right? So like as you can see that we have this virtual layer provided, so we are using DFS commands to store the file. We think we are going to store it under the same under the location like /data /xyz folder, /some file. So this is the SDFS path when where we are copying the file using SDFS commands. But internally, as we understood that there are programs running on these machines which divides your file into multiple physical parts and store it into these slave machines. So that is what we call it as partitioning the data. And same way, if you want to read it, you will just give this location and tell the Hadoop that I want to read the data from here. So what Hadoop does, again there are programs running in these machines will know that this file was divided into this many parts. So it will read all these parts from these machines physically and then present you the entire data in the same order. The order also have to be maintained. First part A, then B, then C, then D, right? So this is called act of partitioning and departitioning a data, which is basically have to be very accurate. That means partition tolerance. So system should be capable enough to have this partition tolerance. Okay, it should be able to basically give you this partition tolerance functionality. It should not have even 1% error on partitioning your data, and then while reading it may mismatch the order or it may lose some data. That should not happen. Otherwise, the whole point of using distributed system is basically nullified, right? So that is what we mean by partition tolerance. So any good distributed file system should support partition tolerance accurately. So this is a CAP principle which Hadoop also follows. Okay, so that is just what I wanted to give you an idea. So are we clear? Any doubts on CAP principle? Okay, fine. So let me also go ahead with some other details. So let's say now this is your cluster. I'll also give you a few more important information about Hadoop. So let's say one of the machine goes down in this cluster. Does it mean that entire cluster goes down? Your cluster should still be operating, right? Even if you have a partial failure in your system. That's called partial failure support. If any machine goes down, your cluster should not be down. Okay, so basically what I'm trying to highlight a point is, even if one machine goes down, your cluster should not be down. It is still functioning, maybe with a lesser performance, but still it should be operating. Now if I add, and if this machine again brought back to the cluster, or if you add one more machine into the cluster, then you don't really need to restart all the other machines which are running in your cluster, right? So which means adding of any machine will also be seamless, should also be seamless. So Hadoop So is a quite flexible framework in that manner. It actually supports this flexibility basically by you can add any machine or you can remove any machine on the fly. You don't really need to restart your cluster to do that. That is why Hadoop is a flexible framework. Okay. Apart from that, it is economical framework because it runs on a commodity hardware. When I say commodity hardware, your laptops, your home machines are also used as one of the slave nodes in the Hadoop cluster. It doesn't need very high-end configuration. So all these machines can be a commodity hardware. You don't need high-end machines to do that. Okay, only the master needs to be of high-end configuration. All the slaves can be a commodity hardware. So setup of Hadoop cluster is in fact cheap, or it doesn't require much cost, but the kind of performance you get with Hadoop is much more than traditional systems. So compared to the traditional system, the cost wise Hadoop is cheaper and performance wise it is better. That is why it is economical framework, and it is one of the reason why it is a favorite choice for many companies to work with big data. Okay, so that is why they use Hadoop to handle and process big data. And also Hadoop is scalable, so it supports two types of scalability: vertical scalability and horizontal scalability. What is vertical scalability? Vertical scalability means, for example, let's say you have one machine, okay, this machine, and this machine has 8 GB RAM, dual core processor, let's say 500 GBs of hard disk. Now I want to improve the capacity of this machine from 8 GB to 16 GB RAM, dual core to quad core processor, let's say, and 500 gigs to, let's say, 1 terabyte of hard disk. So what I'm doing here, I'm basically vertically scaling the system in this cluster. So I can vertically scale any machine in this cluster. That is called vertical scalability without impacting the performance or without restarting the cluster. That is what we mean by vertical scalability, and Hadoop supports that. Now there is something called horizontal scalability. What do you mean by that? So you can add, instead of adding a more configuration to one machine, you can add many machine on the cluster. Okay. So this is called horizontal scalability. All right. Divagaran, other frameworks, for example, like, I mean, the processing of the unstructured data can also be done with Teradata or other traditional systems. But like OpenMPI is there, PVM is there. These are some systems which does support that, which supports distributed processing. And the recent new framework has come up like Spark, which also helps you to process unstructured data much better way. So there are definitely these alternatives. Storm is one which helps you to process unstructured data. Okay. Yeah. So when I'm adding new machines, this is what we mean by horizontal scalability. Basically, you're adding new machines of the same configurations in the cluster, so you're horizontally scaling the architecture of this system. So Hadoop is also supporting horizontal scalability and vertical scalability. Hence, it is a scalable framework. Okay. And it is also a reliable framework because it provides guaranteed availability of the data even in case of failure. So these are the advantages of Hadoop, which is why it is a better choice to work with big data. Okay. So this was the motivation of Hadoop that I wanted you to understand first before we jump on to the architecture of Hadoop. And last but not the least, if you just want to understand the basics of what is Hadoop, right? If you want to just understand the definition of Hadoop, you just need to understand this way. Hadoop is just a framework which is used to basically give you two important capabilities. One is to store data in a distributed manner using HDFS, Hadoop Distributed File System, and they have another component called MapReduce, which helps you to process the data in a distributed manner. Store and process. So HDFS plus MapReduce together forms Hadoop. Okay, so this is that for like if you remember this way, it will be very easy for you to memorize what is Hadoop. All right, so that's the motivation of Hadoop that I wanted to cover. Some of the discussion that we had in this whiteboard are not there in PPT, but it's important that one should remember that, because that would cover a lot of your basics doubts on the Hadoop part. And this is the overview of the history of Hadoop, how it has been evolved. So as you can see, in fact, there should be a time frame maintained for 2003 time frame, where Google has published a paper. Sorry, yeah. Let me just share it. I'm sorry. Can you see it now? So, yeah. So Google has published a white paper on this technology like MapReduce and GFS, where basically they have given these papers, and then later on Doug Cutting was a guy who was working on Nudge project. He implemented these concepts in the project, which was he was hired by Yahoo, and 2006 time frame they have started a project where they implemented this concept MapReduce and distributed file system, which is called SDFS, and they named that framework as Hadoop. Okay, there was a funny story how the name came for this framework. So he saw one day his son playing with a toy elephant. His son used to call that elephant as Hadoop, and that's how they named that entire framework as Hadoop. So there was no logic behind why Hadoop name came. Okay, this was the reason. And then Yahoo has done a lot of case studies with that Hadoop framework on, and they tested it. A 4,000 node cluster with Hadoop was tested by Apache as well as Yahoo on different case studies, and then once it was proving it was giving more better performance, it was made it as an open source, and it became a top level project of Apache. Since then, companies like Facebook, Yahoo, Cloudera are the regular contributors to the Hadoop source code. Okay, what is Cloudera? Cloudera is a company formed by the same guy called Doug Cutting, who is the father of Hadoop. Okay, and from there onwards, now Hadoop has been used extensively by various corporates. So this is just how history evolved for Hadoop. Okay, so this was just a history of Hadoop. So latest version of the is around I think Hadoop 2.6. That's the latest version. And I'll be sharing you the document which helps you to install Hadoop with the latest version only. Okay. So what we have covered is we have covered big data basics, why big data is important. We have covered what is Hadoop, what is distributed file system. We have also covered what is the motivation for Hadoop to be chosen as an effective technology to work with big data. So we have basically done some introductions with respect to these concepts. And tomorrow onwards, we'll make a deep dive into these technologies, and we'll go towards architecture. We'll also understand how to set up the Hadoop cluster, and then we'll take it from there. Okay. So that's what that's what all I have for today's session. We have one activity called polling, where we take polls. It's like voting from all the people, right? On like how are we doing with the sessions. So I'm opening a poll with everyone. It's just one question. You need to select the appropriate answer, and that would basically be recorded for me. So I would encourage everyone to fill it up. I could see one person has not yet done, so can you please finish it? Okay. Also, one more thing, at the end of this session, you will have one feedback survey which is presented to you on your screen once you, close this meeting. So we will encourage you to please fill up that feedback survey as well. Thanks everyone for your, poll result. So as I said, we will encourage everyone to fill up the feedback as well for every session. Yes, Raj, you will get this recording. Yes, Shantanu?
नहीं उसको चेक करके दे देना चेकबुक है ना पास
Okay. So, no, Mano, we don't cover Spark and Scala. It's a separate track of the training. However, at the end, I will give you a little bit overview on Spark, but we don't really cover them extensively in this training. By the way, Raj, to answer your questions, we will get this recording from Simplilearn team. So Simplilearn team is responsible to share this recording with all of you. They'll be sending you after 24 hours of every session. Okay? Yes. Any further questions anybody has? So I hope all of you have enjoyed today's session, right? And we'll have great learning going forward. We'll be making a deep dive into these technologies, and we'll learn a lot going forward on the architecture front and doing a lot of hands-on exercise as well. Okay. So anybody wants to have any more questions? Thanks, Mano. No, Uday, no, actually. So, Uday, Vijay, I think your questions are related. You don't really need to go through any setup or any prerequisites today. I will tell you when something is required, okay, over the period of time. Today, nothing is required for tomorrow's session. You can always come back without any installations. I will help you understand what softwares and hardwares you need for installation later on in today's session. Okay. Yes. Anyone else wants to ask anything? Mary, as I said, the installation part will cover tomorrow. Yes, Mano, definitely. There will be a lot of hands-on exercise we'll be doing, and you will get to understand a lot about them. All right, everyone. So with that note, we'll call it a day. We'll meet tomorrow at the same time, and we'll continue from there. Okay. So have a good day, all of you, and see you all tomorrow. I'm going to unshare the screen. I'll be closing the session. So thank you once again, everyone, for your time, and hope to see you tomorrow at the same time. Have a good day. Thank you, everyone.